So I'd like to start today by introducing you to my friend Julia. Julia and I have known each other for a long time, probably over 20 years. She started off as a scientist like myself, but decided to change careers. She also married a farmer, and that also helped in her changing of careers. But she wanted to become a farmer herself, and this is what she's now. But we still keep in touch quite a bit, especially through social media, and she's in Smoky Lake. And just like her, we have young children around the same age. She has 3, I have 2. And their farm grows free-range animals, including pigs and poultry. And she's way busier than I am. Amazing products that they sell, and vegetables as well. And one of the big differences between Julia's children and mine, even though, as I said, they're about the same age, is how much time they spend outside compared to mine. Even though I do try to take them out for walks, and we have pets, and we try to keep them outside, we're city people, and they're not. And except for when they're in school, these kids are really outside all the time. They have to help, and they don't want to stay inside. She just sent me a few pictures because I asked her, like, you know what? Sometimes I give talks about the microbiome. I'd like to know how your kids look like when they come home. And this is during the summer. Sometimes they wear shoes, sometimes they don't. When they come in, their feet look like this. Maybe once or twice in the year, my kids' feet will look like this, but that's about it. And that's usually when we're on vacation. This is her youngest one, June. And more often than not, this is what you'll see. She learned how to walk in a barn. And this is just super common, a super common occurrence. And even though she says that she tried to keep her house clean and tell them to, leave their dirty stuff by the front door, that rarely happens. It's usually very common that the dirt makes it into the house as well. And on a good day of harvest, this is how all of their hands look too. In her house, like a daily bath is not just something that you do because you want to give the kids a bath. This is very much mandatory. And one of the interesting things is that she says that the water, the bath water, is dark, is really dirty at the end of the day. That really has never happened to my children. So the reason why I like to tell that story first is because there's now really convincing research and many papers that have come out in the past decade or two that are showing us that kids in farms versus kids that are not, they're not only different because they're dirtier, but because the risk to develop diseases is very different as well. So just by being born and raised in a farm, Julia's kids have a much lower risk of developing allergies and asthma, but also becoming obese and developing autism, which are diseases that have skyrocketed in Western populations, and that we still do not understand why. One of the reasons that we're now exploring is the role of the microbiome, and I'll be explaining what that is in a little bit. But before that, I want to show you this graph. So on your left, you will see something that is very good news, as something that we owe to modern medicine and scientific discovery. So this is the change in incidence of some of the most severe infectious diseases from the 1950s to the year 2000. You'll see rheumatic fever, hepatitis A, measles, mumps, tuberculosis, etc. Some of these were very common in the 50s, and you would know someone that had any of these. Right now it's very rare, and it's really thanks to hygiene, it's thanks to antibiotics, and it's thanks to vaccines. Those are the 3 major medical breakthroughs that have decreased the incidence of infectious diseases. which is great. But then when you look at the other graph on your right, you're not seeing infectious diseases anymore. You're seeing diseases that are known as immune diseases, meaning that there's something wrong with the immune system that makes this disease develop. And if you look at the same amount of time, those, as I mentioned before, have skyrocketed. So we look at multiple sclerosis, Crohn's disease, which is quite a common occurrence in Alberta in comparison to the rest of the world, as well as type 1 diabetes, and as I was talking and alluding before in terms of the difference between Julia's kids and mine, asthma and allergies. And what we're starting to learn is that these two phenomena are not just correlated. They're not just, one is happening in parallel than the other. We're now understanding that there's something that happens early in life that has to do with microbes that can alter the way our immune system develops. And because we've gotten so good at getting rid of infectious diseases, inadvertently, we have caused changes to the immune system of little children. And this has happened at a massive scale, at a population level scale. Now, that's not to say that antibiotics or vaccines or hygiene are bad. Quite the contrary. They're amazing. If you had to choose whether you want your kid to have a high risk of all of those diseases or the other ones, odds are that you would really not want them to suffer from infectious diseases. But at the end of the day, what we're learning is that both of them are connected and that we have to become smarter when it comes to dealing with microbes. And this is what we're going to talk about today. So I told you that I was going to talk about the microbiome and define it. And for some that have been here before, this will be a repeat by the end of it. If you've been here for the 4 seminars, you'll be experts and you will be able to answer what the microbiome is to anyone. But for those of you that are new, the microbiome is this very large community of microbes that lives in and on us. The majority of this microbial life resides in our intestines, mainly in the large intestine. It's a very large number of cells that lives there. It's a 10 to the 13, which is a 1 followed by 13 zeros. And just to put it into perspective, this is actually higher than the total number of cells in the human body. And it is not only a very great number, it's the fact that these cells are alive, just like our cells. They're alive and they're reproducing and they're making molecules and they're making compounds. And even though most of them live in the gut, it's not that we excrete them when we go to the bathroom. We have really clever adaptive mechanisms or ways to absorb some of this output or some of these things that the microbes are producing, and we incorporate these things into our own physiology. We have come to learn that our physiology is not only dictated by our genes, but also by the genes of the microbes that inhabit us. And this is very new. It's only been known for the past couple of decades. This idea that the way we develop and the way we function is not only human, but is a combination of human and also microbial. And it seems that it all starts when we're born. We're born sterile. There's really no microbes when we're growing inside of the womb. But as soon as we come out, ta-da, we go through the vaginal canal, which has a lot of microbes, and we get impregnated with microbes. And then from then on and until the moment that we die, we have to live in this crosstalk or in this connection with microbes. And there's now been a mounting amount of evidence that is very convincing and that it shows that microbes carry out very important functions for our physiology. It's really important in training our immune system, as I was alluding to before. So when we're born, our immune system, just like many of our systems, is very immature. And now we understand that part of this immune education that happens early in life relies on the signals that microbes produce, not only on hereditary issues or not only in things that are encoded in our genes. We now understand that the same is true for our metabolism, meaning the way we process food and the food gets absorbed and the amount of energy that we obtain from food. And this is from different experiments that have compared animals, in particular mice, with and without microbes, and understand that not only do they weigh less, but the animals without microbes, despite the fact that they eat the same amount, but if you give them microbes, then they gain weight. So microbes have specific ways of changing the way food is digested and the way it's absorbed. And then finally, and in a very fascinating turn of events, we're now understanding that microbes also help dictate the way we behave. They produce many substances that travel from the gut to the brain, known as neurotransmitters. Perhaps you've heard about serotonin or dopamine or GABA. Many of these have their building blocks starting from the gut and depending on the activities of these microbes. So very much the way we develop and the way we behave is not only human, but it also depends on the type of microbes. A little while ago, I was involved in a series of studies that followed Canadian babies from birth till we're still following them. Most of them are about 8 years of age. And luckily, the folks that designed this very clever study across Canada decided to collect stool or diapers from these babies. And when they designed this study, this really predated what we knew about the microbiome. So in a way, this was quite serendipitous. When we looked at the stool samples of babies at 3 months of age, and we studied the microbiome, what kind of microbes were in these babies. And then we compared, because we had what is called longitudinal information. We knew what happened with these babies as they grew. We knew that some of them remained healthy, but some of them developed asthma. And we could detect some differences at 3 months of age that allowed us to predict whether the child was going to be in the healthy group or the child was going to be in the asthmatic group. Now, up until then, we were really intrigued by this, but at the end, this was really an association. This was not really showing that microbes were potentially causing this. But we took advantage of these germ-free mice, which are very important tools for research. They're also very hard to work with simply because it's really hard to have a germ-free facility. If you can imagine, every habitat in this planet has microbes. So engineering a place that completely removes microbes is quite the challenge. And luckily, we have a facility like that now at the University of Calgary. So we took advantage of the fact that we have germ-free mice, and we gave them 2 different settings. Half of the mice had the same microbiome of the babies that went on to develop asthma. And then the other half of the mice had the same microbiome, but we gave them the 4 bacteria that were missing in those babies that went on to develop asthma. And what was very interesting was that just by doing so, just by adding these 4 microbes, we found that these mice were a lot less prone to develop asthma later on. And for the first time, we understood that even though asthma is an immune disease, it can be changed, its severity can be really modulated or changed by changing the type of microbes that in this case, mice get exposed to. So as I mentioned before, things are important very early in life. And when it comes to microbes and to many things, everything starts at birth. But of course, not all births are the same. There's 2 ways of being born. You're either born by C-section or you're born vaginally. And as we understand now, and this was quite surprising too, from the microbiome point of view, that those 2 ways of being born is quite different, because the type of microbes that live in one part of the body can be very different to the type of microbes that live in another part. the vaginal canal has a type of microbiome that's quite unique. It's quite specific to that body site. And of course, when the baby goes through the vaginal canal, it's going to be colonized by these microbes that are common in that area, at least initially. Babies that are born via C-section tend to be colonized by microbes from the skin or from hospital environments for the most part. We also now understand that one of the most important factors that dictates what kind of microbes we're going to have as we grow is our diet. And when babies are not eating solid foods, again, there's mainly two forms of feeding. They're either fed with breast milk or with formula, or with a combination of both. And it's very interesting because if one looks at a microbiome study of babies at this age, you can tell whether, very easily actually, whether a baby is being breastfed or not, only based on their microbiome. Microbes are very much what we eat. And from the microbial perspective, the microbes that are able to digest and to thrive on breast milk are quite different than the ones that can thrive on formula. And combined with mode of birth, we also know that being born by C-section and being formula fed does increase the risk of certain diseases, including asthma and allergies, that we know have very strong connections to changes in the microbiome. So we've come to understand that the microbes that come early very much matter, and we're now in the phase where we're trying and pushing to understand which exactly are the microbes that matter and what are the lifestyle factors that help us get them or not. And then as this baby grows, he or she will start eating food. And just like what I said about breast milk and diet, nothing is more important to the type of microbes that we grow than what we eat. And one of the things that the microbes that live in our colon, or at least some of the many beneficial microbes that live in the colon, that they're experts on, is on digesting fiber. So fiber is this component, this fibrous component of plant-based foods. And you find it in fruits and in vegetables and in whole grains. And we really do not have the enzymes that can break down fiber in order for us to gain energy from fiber. This is one of the things that we rely on microbes for. The problem is that if we don't eat enough fiber, we can extinguish or we can starve some of those microbes that also depend on that, which is why I put a baby eating broccoli. Because if a baby is not administered enough amount and variety of fibers early on, odds are that this baby is not going to be able to harbor a proper diversity of microbes as he or she grows. So with this information, myself, even though I've been studying this for a few years now, as a parent, I found myself in a bit of a conundrum. Because on one side, I know as a microbiologist that one has to take very direct and important measures to prevent infectious diseases. But on the other hand, I'm learning and I'm telling you that we also have to expose ourselves to microbes. So how do we figure this out? And the quick answer is that we still do not know for sure, but we do know some things, and I'll share some of these with you. The most important one being that there isn't a black and white in terms of you can do exactly this and you can do exactly that. But there's definitely guidelines that one can follow in order to try to balance those out. And the idea today is to go over certain practices relevant to hygiene and the way, how dirty we allow kids to grow. And after I present some of these questions, I'll open them to the public. And I find that whenever I give this talk is very interesting. I often find the questions that you bring are the more interesting ones, not the ones that I present. So before I start with the Q&A today, I'll define what hygiene is. So hygiene is the conditions and practices that help to maintain health and prevent the spread of diseases. Hygiene has really nothing to do with how sparkly clean we are necessarily. That is what I may call hyper-hygiene. This idea that we need to disinfect ourselves may actually not necessarily reflect to the main concept or definition of hygiene, which is this practice to prevent diseases. That means that dirty does not necessarily mean disease, because as you know, disease doesn't just appear spontaneously, or I mean infectious disease doesn't appear spontaneously. You need a carrier, you need an agent, a microbe that will transmit this disease. And also, as I said before, cleanliness does not equal hygiene either. And if there's anything that I like you to take home today is this concept of how important hygiene is, but what really is hygiene? So, one of the most important measures related to hygiene is hand washing. And luckily, hand washing, because it started so many decades ago, it's one of the medical practices that has been better studied and documented. We know very well how effective it is and when to do it in order for it to be effective in the context of hygiene, in the context of remaining healthy and preventing infectious diseases. And I think we've all heard this before when we were growing up in kindergarten, right? We need to wash our hands before we eat, after we use the toilet, if you're sick or in contact with someone sick. And in that case, if you're caring with someone that has a cold or a flu or something infectious more serious, you do that often during the day in order to remain hygienic and prevent disease. After handling garbage, decomposing food, animal waste, farm animals, after being in places frequented by many people, and this is something worth mentioning because no one makes the connection. Diseases, infectious diseases, are transmitted in communities because there's a higher density of people, of carriers of disease. So if you find yourself that you move yourself using the metro system in New York City or in Paris, where you know that there's going to be thousands and thousands of people there, the risk of disease goes high, way higher than if you just drive your car in Northwest Calgary to go to the university. So that really changes however many times you should feel inclined to wash yourself during the day in order to prevent disease. But, and these are the not in blue in that slide, you don't have to wash your hands after playing outside. This, of course, is for kids, unless, of course, they were playing with someone that was sick, or they encountered something that was decomposing, or they were playing in the metro station in Paris. But just for being outside and playing in the yard, a child does not really need to wash their hands. Not after playing with other children, too, of course, unless they were playing with someone that was snotty and sick. And you don't have to do it all day long. So this practice that you see, and I see it in the school that my kids attend, where so many kids have the antibacterial gels hanging from their backpacks, is not only not effective, it's not really going to change the risk of a child potentially getting sick, but it may actually be detrimental to the type of microbiomes that we should be in contact. We do not need to completely limit our exposure to microbes. We do need to take measures to prevent the spread of disease. And the reason why I think is very important, and I used a bigger font, is that we shouldn't do it with antibacterial soap. I mean, antibacterial soap has a very important place in several settings. If you work at a hospital, or if you had to go to the hospital, of course, there's a place for antibacterial soap. If you're going camping for a week and there's no running water, it makes sense that you bring some antibacterial soap. But for everyday use, there's no reason to use antibacterial soap. And what's really interesting is that studies have also shown that antibacterial soap is no more effective in preventing diseases, even in endemic areas, than regular soap. So for everyday use, we don't really need antibacterial soap. The other interesting thing about antibacterials is that it's not only in soaps. Like try it out. Go to the supermarket and go to the place where you buy soap and creams, and odds are that they are going to have triclosan, or they're going to have another antimicrobial, including toothpaste, including sometimes the gel that you put in your hair. You can find antibacterials now even in fabrics, in many places where you don't really need antibacterial. So it's a bit tricky. You kind of have to get out of your way to find non-antibacterial soaps and products. This is one that when we were writing our book, and I'll mention a little bit about this book later, we got from parents. We surveyed a lot of parents, and we got from them a lot. And I remember thinking about it too when I had my young kids. Should people hold and touch my baby? So I'll start telling you a couple of really neat studies that have looked at the microbes in families. They've also looked at in human families, and they've also looked at the microbes in families in monkeys as well. And what they have found is that when people are closer to each other, or where monkeys are closer to each other, there's some monkeys that groom each other, there's some monkeys that don't, they have closer microbiomes. They have more evenly distributed microbiomes. And if you lose that physical contact, you limit that spreadability of microbes. So there's now good evidence that actually touching someone will help spread your microbes. And knowing that the majority of microbes are beneficial, one can think of this as a mechanism to also spread good microbes. Now, this is in general. When a baby is very little, when you have a 2-week-old that has not been vaccinated, you also want to be careful. So what we know is that, yes, of course, babies can be touched and held by other people, as long as you follow hygiene measures that we know. So ask people to wash their hands, and make sure that you don't have visitors that are sick or sneezing or have been sick recently. And usually that means limiting the contact that they have with other kids. Of course, that's not going to happen with the siblings at home. That would be impossible. But for sure with people that are not from the household. So in general, physical contact, thumbs up, very positive when it comes to the spreading of microbes, but do so in a way that limits the spread of disease. Another one that was a popular one related with hygiene. If my child is sick, should I keep her or him at home? Or is it good for kids to share infections? And there's a lot of myths regarding this. I remember talking to a mom that told me that when she was growing up, her mom held a measles party. So there was a whole bunch of kids. One of them had measles, and they just gathered them, family kids and neighborhood kids, because they all kind of wanted to get it over with. Now, measles now is a preventable disease with vaccines, but the same idea could apply if you thought of the common cold. However, there's very good evidence that getting sick with severe colds or flus when you're young actually is detrimental to your immune system, not only then, but in the future. So kids that develop a lot of respiratory diseases in the first year of life have a much higher risk of developing asthma by the time they start school. Of course, that's not to say that kids should never get sick. Getting the common cold is almost part of being human, especially when you live in a society. It's very common. But what I mean by this is that it also makes sense to try to protect children from getting recurrent colds or recurrent infectious diseases, because our immune system takes a hit from each one of them. And these hits can accumulate in a way that can be detrimental. So impossible to grow without infections is going to happen, but it makes sense that if our kid is sick, to try to keep him or her at home as much as possible, not only to limit the spread of diseases, but also because kids recover faster if they can rest, if they can sleep, than if they just go to school. Now, and this is, I think, also a good slide to talk a little bit about vaccines, which especially nowadays seems to be a little bit of a contentious issue, which is new. A couple of decades ago, it wouldn't have been a contentious issue. So very neat studies that show that vaccines, that by the way, are one of the safest medical treatments right now, even safer than ibuprofen and Tylenol. Getting vaccines early in life is going to reduce a baby's chances of getting ear infections, which is also very common in the first 3 years of life. Now, what happens when a baby gets an ear infection? They're going to have to get an antibiotic more often than not. And antibiotics can be quite detrimental to the microbiome. Now, if you have to use them, you have to use them, because the risk of a very severe infection developing from an ear infection is much higher than whatever can happen to the microbiome from using an antibiotic. But if there's anything that you can do to protect a growing microbiome, is to prevent the need to using antibiotics. If they need to be used, they need to be used. But if there's anything that one can do to prevent their use, it's also a good idea. And one of the best ways to preventing antibiotic use is by completing a full course of vaccination early in life. What about dirty stuff? Well, the thing with this, can kids touch dirty, is that not all dirt is the same, of course. So it's impossible. This is one of the things where there's really no black and white. There's a lot of gray area here. Yes, of course, if we couldn't touch dirt, the human species really couldn't exist. Dirt is also part of being human. There's different gradients of how much dirt, but everyone is in contact with dirt. So in general, kids should be allowed to roam free and develop what it's a very innate instinct to get dirty. And if anyone here has raised children or been in contact with children, you will see that they almost wait for us to turn around to get the dirtiest stuff that they can find and shove it in their mouths or anywhere. So I think it's part of their instinct to do that. And in any way, I don't think we should limit that, as long, of course, that they're not in an unsafe, hazardous place when it comes to microbes. And if you're in a metro station, or if you're at the airport, or if you're in a place where there's a lot of people and the pacifier falls to the ground, then it's probably not a good idea to pick it up and put it in the kid's mouth. But if you're at home, or at someone else's home that you know, and you know that, the place looks decent, not dirty, then it really is no big deal. The same thing with allowing them to get in the yard and get as dirty as they want. So not places are the same. So good idea to avoid touching, licking, or playing in places that see a lot of people, as I said, but for sure, let them roam free. If there's anything that kids have a deficit now, is of green spaces and roaming free. So we should advocate to change that. Another one that to me was a surprise, but it is a very common practice, is the sterilization of milk bottles. And of course, this applies to the very young stages. Is it necessary to sterilize milk bottles? And the answer is no. No, period. And this is according to both the American and the Canadian Pediatric Societies after many, many studies. Usually when these societies make a recommendation is from a very concise body of scientific work. They usually don't do it out of 1 or 2 studies. So what the recommendation is that for the first time use of bottles and all, baby bottles for the most part, but pacifiers too, is to clean them in boiling water or the hot cycle of the dishwasher. This is for first time use. But after that, to clean them the same way you clean your dishes at home. And this is with soapy water, or just use the regular cycle of the dishwasher. If you think about it, how many generations of human life happened before we started sterilizing milk bottles? It's actually been studied that the risk of transmission of an infection or a foodborne illness from a non-sterilized bottle is actually non-existent. It does have to be clean. And for that, one has to be careful to get into those tiny spaces in a milk bottle and make sure that they're properly cleaned, but they do not need to be sterilized. Another interesting one, are sandboxes unsanitary? Again, and this one is linked to the question regarding dirt. Not all sandboxes are the same. In general, yes, they're mostly safe. They should be kept covered though when not in use, because animals love sandboxes, not just cats, but other animals, for whatever reason, like sandy surfaces to go do their thing. So if you see that there's a sandbox that has animal waste, do not use the sandbox, of course, and report it, especially if it's a sandbox of public use. And it is, though, recommended to wash your hands after using a sandbox. Because sometimes you may not see if there's animal waste, but there may have been a small amount that you cannot see. So it is a good measure to wash your hands after. Should I allow my child to eat unwashed fruits and vegetables? And this is, following this idea that some people may think, dirty is better. And to some degree it is, but again, not all dirt is the same. No, we should not allow children or anyone to eat fruits and vegetables that are not washed properly, because it has been shown that this is a source of foodborne transmission, infection transmission. So the water that is used to irrigate crops is not really potable water in many of the cases. So there is a risk of developing a potentially very dangerous infectious disease if you don't wash vegetables. Now, it's a different thing if you have an apple tree outside and decide, you know what's happened in that particular apple tree, you feel free to have a bite on that apple, but definitely not in crops of commercial use. It doesn't matter if it's organic or not. The way crops are irrigated really doesn't change that much on whether it's organic or not. So I'll leave you with those thoughts today. I'll be happy to answer any other questions that you have. Another take-home message for those of you that came here with children, have children, grandchildren, work with children, is to try to envision this, which is this idea of your children and yourselves, but we're talking about children today, of being both human and microbial. And sometimes it's not that hard to, it's not that hard to do, because sometimes they're looking pretty grimy and microby, but to think about their health as not only their human health, but that you also have to help and take care of their microbiome. Before you go, I'll introduce you to a book that myself and another Canadian microbiologist wrote 3 years ago. It's called Let Them Eat Dirt. This wonderful gentleman here from Owl's Nest Books has it for sale. Of course, I'll be patting my own back, but I say that I really like my own book. It will be a very biased opinion. But what I'll say is that there's a lot more information. So if you're interested about this, if you want to learn about other issues regarding the microbiome, diet, things that you should do, things that you shouldn't do based on actual research, because this is what we do, feel free to look at it. If you choose not to buy the book, there's a website called letthemeatdirt.com where there's some resources and information as well. And that's all I have for you. Happy to answer any more questions, and thank you so much for being here.